Hello friends, in this video we will be using the formulas developed in the last video for the evaluation of first and second derivative of a function. So this one is the forward difference, this is backward difference, and this is the central difference for the evaluation of first derivative, whereas this is the formula for the evaluation of second derivative, and this is also central difference. So this formula and this formula, they both are having an order of accuracy of h square. So let's say you are interested in differentiating the function 3x squared plus 2x plus 5. So if you differentiate this function, you will be getting 6x plus 2. And let's say you wanted to know what is the value of the function when x is equal to 1. So it is 6 plus 2, that is 8. Okay, so let us head to the editor and write the program. So first we will be writing the function. So let's say float, because every mathematical function, whatever we are evaluating, should always be returning, or we should always be writing it as float, because that always returns somehow the float values only. So f and then x and then return. What was the function? The function was 3x squared plus 2x plus 5. 3x squared plus 2x, oh, where am I writing? It is 3x squared plus 2x plus 5. Okay, now this is the function. Now we have to declare the value of x. Let's say it is 1. Take the value of h. Let's say it is 0.5. Or some lower value, let's say 0.3. And then apart from this, we have to declare different variables for df dx. Let's say backward difference, df dx, backward difference, central difference, df dx, forward difference. Okay, so df dx forward will be what? This will be fx plus h minus fx, and that whole is divided by h. What about the backward difference? Let us copy this. The backward difference will be fx minus fx minus h divided by h. What about the central difference? So this is fx plus h minus fx minus h by 2h. And then comes the second derivative. Let us also write the second derivative. So d2f dx2 is equal to, let me copy this one. This is equal to fx plus h minus 2fx plus fx minus h by h square. Okay, and then finally print them up. Printf, the forward difference, first derivative, so it is df dx forward difference is equal to percentage f. Let's restrict to 4% of decimal, and then this is df dx forward, and then come to new line, and then backward. So this is backward difference. So this is b, and then comes the central difference. So this is c, and then comes the second derivative. So it is d2f by dx2. d2f by dx2. Here also we are writing d2f by dx2. And let us run it. So it is saying that this d2f by dx2 has not yet defined. So let us define it. Okay. Now, what you can see? You can see that you are getting all the values 0. Okay. But why you are getting all the values 0? Now, the reason is you have declared this function and you have not told the function itself that what is the data type of this. So this is float, and now run it. Now you can see, now this is a very important thing, huh? You should remember that whenever you are writing arguments, so you should always be writing the data type of those arguments. So here, the first derivative in forward direction is giving 8.9, backward direction is giving 7.1, and central difference it is giving you 8. And our analytical answer was also 8. Okay, so that's why I said that this is very accurate. Apart from this, if you evaluate the second derivative of this function, that is f double prime x, so this is 6, and that is what we are getting there, 6. Okay, so if you want to increase the accuracy of forward and backward difference, then what you have to do is you have to reduce the spacing between data points. So if this is, let's say, instead of 0.3 I take 0.001, then all the values will come close to 8. So it is 8, it is 7.99, it is 8. Okay, and here there is a slight deviation because that is a constant value that is coming as a constant. So that's why there is a deviation. Okay, so friend, in this way, what you can do is you can evaluate the derivative of any function. Not only this, you can also go for trigonometric functions also. So let's say I want to evaluate the derivative of sine x. Okay, so I have used this. Okay, so function is sine x. So let's say I'm interested in knowing the value of this first derivative of this sine x at 0. You know the first derivative of sine x is what? Cos x, and cos 0 is 1. Okay, so let us take point 1 as this, and let us run it. So now you can see the derivative of sine x. First look here, d by dx of sine x is what? Is cos x. And if I place 0 here, so this will come out as 1. And d2f by dx2 of this sine x will be what? Cos x, derivative of cos x, which is minus sine x, and if I place x is equal to 0, so it should be 0. So that is what this is happening. This is giving you. So this is 0.99 very close to 1, this is 0.99 very close to 1. So they all are giving the value as 1, whereas this is giving you 0. So in this way, you can make your own function, you can differentiate your function, and that's it. So thank you very much in this video till this point only.